Welcome to Simplified Learning, and in this video we are going to see MCQs 101 to 205 for cement and concrete properties as continued from previous video. Specifically, we will be talking about workability, various types of cement, white cement, OPC, blast furnace cement, higher strength cement, air entering, and several other kinds of cement. So let's go to MCQs itself. Let's go to MCQ number 1. What is the definition of workability in context of concrete? See, the definition of workability is that the ease with which concrete can be mixed, placed and compacted without any excess segregation or any problem is called as workability. Therefore, the answer goes as concrete's capacity to be mixed easily and placed without segregation. Out of these four options, the most appropriate one is option C. Then question 102. What are the various three main aspects of workability? Let's see option A. Compressibility, strength and durability. No. Plasticity, porosity and density. No. It is not. Mixing, curing and finishing. It is option D. Mixing, placing and compacting. The ease with which the concrete mix can be mixed or placed and placed and compacted. Okay. Then let's go to C. Answer is D. Let's go to question next. What is the significance of achieving good workability in concrete? See, having good workable concrete improves the durability and quality of concrete. Means whatever the structure that we are constructing with a well workable concrete, the durability of the structure increases. The quality of concrete, obviously the quality of structure will be good. That's why the answer is C. Cost of construction is not an aspect. Permeability is not an aspect. Decreases the setting time is not something that has to do something with workability, right? Then question 104, which factor has the most significant influence in the workability of concrete? The answer is water cement ratio. Okay, the fluidity of the mix will be mainly governed by water cement ratio. To some extent, aggregate size, yes, it does matter. Cement type, slightly it matters. Temperature, not, let's not say not at all, but to some extent it will be there. But the most appropriate answer here is the water cement ratio. What kind of water cement ratio you are having, it will be governing what will be the workability of concrete. So the correct answer is option B. Then, how does an increase in aggregate size affect the workability of concrete? See, aggregate size, finer it is, more workable is going to be the concrete. Then coarser it is going to be, then it is going to reduce the workability or fluidity of the concrete mix. Thereby, the correct answer is reduces the workability. More large size aggregate or coarse size aggregate, excess of coarse size aggregate, if it is in there in concrete, then it is going to affect workability in negative way. Means it is going to reduce the workability, right? Then the effect of using a high water cement ratio on workability. Obviously, more water cement ratio, then it is going to increase the flow property. That is, it is going to increase the workability, right? Then how does the use of super plasticizer impact the workability of concrete? See, super plasticizer increase the workability, right? It add on the workability aspect of concrete. Then what is the influence of higher temperature on workability of concrete? Okay, higher temperature reduce workability. See, high temperature can accelerate setting time and thereby reduce the workability due to faster evaporation. Means water will be leaving the concrete mix and thereby making the concrete less workable, right? Then the primary impact of excessive compaction on workability. Higher compaction is going to lead to segregation. Segregation means setting of coarse aggregate to the bottom and leaving the concrete paste onto the top, cement paste onto the top. It is called as segregation. More or excess compaction is going to lead to segregation and thereby the homogeneous mix of concrete is going to lose its workability. Then how does the addition of entrained air affect the workability of concrete? See, the entrainment or air entrainment is going to reduce the workability, but it has another importance that enhances the freeze thaw resistance, specifically useful in colder countries, right? Thereby the answer is it reduces workability. Then which factor has the minimal effect on concrete workability? It is going to be cement content, right? Aggregate shape to some extent it has, admixture type mostly it can affect, temperature yes, but cement content to some extent they are the same, okay? Whatever the cement types are there, then workability is not going to get affected by what cement content is there, okay? More or less the cement content is going to be the same with some slight difference. Then what is the recommended range for good workability as per IS 456-2000 says that 10 to 25% is the range of good workability. Then how does the decrease in workability affect the ease of concrete placement? See, decrease in workability is going to result in mixing difficulties, then placing difficulties as well as compacting difficulty. Thereby it is going to make placement more difficult, means whatever place or whatever cast or whatever mold you are going to put concrete, the decrease in workability is going to make that placement process more difficult, right? Then how can a lack of proper workability impact the durability of concrete structure? See, it is going to reduce durability, okay? Less workable concrete, if it is being placed somewhere, then it is going to cause a reduction in durability, okay? Improvement not a seen, no effect, not at all. Then accelerate setting time, it has nothing to do with lack of proper workability, right? And what is the primary effect of using excess water to achieve high workability in concrete? See, increasing water quantity is going to improve workability. It is okay, it is going to make highly workable concrete, but the problem is it is going to increase permeability, right? Water will be leaving the pores of the concrete mix, then it is going to leave some spaces, it is going to leave some void. That's why permeability of the concrete is going to increase. Then role of cohesion in concrete workability. See, cohesion is the property by which the particle, the matter is going to adhere with each other, bond with each other, okay? Cohesion is going to increase the ease of compaction and placement, right? Role of cohesion in concrete workability is it is going to enhance the ease of compaction and placement, okay? Which type of concrete mix require higher workability for proper placement? See, it is the lightweight concrete. Lightweight concrete requires higher workability for proper placement because it has low density, okay? Then effect of using well graded aggregate. See, aggregate grading, if it is proper, then it is obviously going to increase the workability, thereby it improves the workability, right? Reduction, no. No effect, no. Then setting time, it has nothing to do with well graded aggregate, right? Then primary impact of using larger percentage of fine aggregate on workability. See, it is going to increase the workability, it is going to improve the workability, okay? Finer the aggregate size is there, then fluidity, the flowability of the concrete is going to increase, thereby it will be having great workability, okay? Then how can workability influence the required compaction effort during construction? See, higher workability means more compaction effort is going to take place there, okay? More compactive effort is required over there, right? That's why the answer is C. Higher workability requires more compaction effort. Then how does the workability affect the potential for segregation in concrete? See, higher workability means more fluidic concrete, more flowable concrete, and thereby high water content ratio is going to be there, which is going to lead permeability problem. Then segregation risk also increases, because when we are saying that workability should be higher, then we are maintaining high water cement ratio, then it is going to cause the problems like setting of coarse aggregate to the bottom, which is segregation. Thereby higher workability increases the chances of segregation, thereby increases the segregation risk. Option C is the right one. Then what is the primary impact of poor workability on the finish of concrete surface? It is going to create a harsh surface, right? It reduces the surface quality and appearance. Option D is right. How does the use of well-graded aggregate impact the workability of concrete? Obviously, it is going to increase the workability. Then, decrease in water content in workability of concrete. Decrease in water cement content or water content, okay, or water cement ratio decreases. It is going to reduce the workability. More water content, more water cement ratio, higher water cement ratio is equal to increase in workability, right? And when we are decreasing the water content, workability is going to get reduced. Thereby, correct answer is option B. It reduces workability. Then, how does the presence of entrap air affect on the workability of concrete? See, it reduces the workability. We have already seen this one. Then let's see some questions regarding OPC, that is ordinary Portland cement. What is the primary characteristics of OPC? The answer is versatility in construction applications, right? Then which factor distinguish different grades of OPC such as 33 grade and 53 grade? See, the grade that is 33, 43 and 53, it is nothing but the compressive strength of concrete. Then in which of construction is ordinary Portland cement? OPC is commonly used. See, general construction project means general applications of projects are there, then we are going to use OPC over there. Then what is the typical color of ordinary Portland cement? Means the regular cement that we are talking about. OPC is grey in color, not white, not red, not black. Then which type of cement is often used as a base for producing blended cement with additive? Okay, the answer is Portland pozzolana cement. Okay, OPC is commonly used as a base for producing blended cement such as Portland pozzolana cement. Then what is the main ingredient added to OPC to produce PPC, that is Portland pozzolana? See, what we are going to do, fly ash plus OPC is going to give us what? PPC. Always remember this, OPC plus fly ash is equal to PPC, that is Portland pozzolana cement. How does PPC contribute to sustainability in construction? See, it is using what? Industrial byproduct, which is that, what product is that? Fly ash. Okay, it utilizes industrial byproduct. That's why sustainability, environmental sustainability, we are going to say it is being preserved by PPC, right? And what is the advantage? What advantage does PPC offer in terms of heat of hydration? It has lower heat of hydration. Okay, compared to OPC, it has lower heat of hydration. That's why the problem regarding thermal cracking of concrete is reduced. Then which application is particularly suitable for PPC? Marine structure. Okay, marine structure is best scenario for the use of PPC. Then what property of PPC makes it suitable for projects with extended construction schedules? Okay, the long-term durability offered by PPC makes it suitable for project with what? Extended construction schedules. Then what is the primary supplementary material used to produce Portland slag cement? Okay, the blast furnace slag is mixed so that we can have what? Portland slag cement. Now, how does Portland slag cement, that is PSC, contribute to reducing carbon footprint of concrete production? Since it is using what? A industrial byproduct, which is blast furnace slag. Just like OPC mixed with fly ash was going to create PPCs, in the same way Portland slag cement is going to use the industrial byproduct, which is blast furnace slag. That's why it is going to leave a proper carbon footprint. Okay, answer is B. It decreases the carbon emissions. Which property of PSC makes it suitable for reducing the heat of hydration? Obviously, the answer is low heat of hydration. Large concrete structure means the structure such as dams, where massive concrete is done and where we seek concrete with low heat of hydration. That's why we are going to use what? Portland slag cement, PSC. In which type of structure is Portland slag cement commonly used? It is bridge pier. Okay. How does the use of blast furnace slag in Portland slag cement contribute to its improved property? See, addition of slag improves the durability and resistance to sulfate attack. That's why we are using it in bridge pier, where the pier may be in direct contact with water. And what is the primary characteristic of rapid hardening cement? Okay, the name itself is suggesting something. Rapid hardening cement means it is going to set rapidly, easily, and high early strength development. Answer is B. Then, how does the rapid hardening cement, let's call it RHC, contribute to efficient construction practices? It allows for fast formwork removal. Okay, because it is setting early, it is gaining strength early. That's why we can remove the formwork easily and early. Then, which application benefits most from the use of RHC? That it can be used in precast concrete elements. See, early strength development and quick formwork removal enables it to be used in precast concrete elements, right? And how does RHC affect the overall durability of concrete structure? It is going to obviously improve the durability. Okay. Then what are the key factors to consider when using RHC for construction project? If lower water cement ratio is there, then we are going to consider RHC. Using a low water cement ratio help achieve higher early strength with the rapid hardening cement. And what is the primary advantage of using low heat cement in massive concrete structure? See, in massive concrete structure, if we are going to ignore the heat of hydration, then it is going to cause problems such as heat cracks. Okay, the massive cracks can be seen on the concrete structure after it has properly set because of high heat of hydration. In this case, we are going to consider a mix which gives out lower heat of hydration, right? Obviously, low heat cement is going to generate lower heat of hydration. And in which type of construction is low heat cement commonly used? Mass concrete structure. Okay, remember always low heat cement or low heat of hydration, wherever it is required, it is a massive concrete structure such as dam. Then, how does low heat cement achieve its characteristic property of lower heat of hydration? By incorporating supplementary material, we are going to have low heat cement. Okay. How does low heat cement affect the early strength development of concrete? Okay, it delays the early strength development. Okay. Then what is the primary challenge associated with using low heat cement in construction? Longer setting time is the problem, but low heat of hydration is the advantage. Thereby, with some advantage, we are going to have some sort of problem. But looking at the bright side of using a specific kind of cement, we are going to ignore the other one. Okay, the answer is longer setting time. What is the primary purpose of using sulfate resistant cement in construction? It can resist sulfate attack. Obviously, sulfate resistance, the name itself, it is suggesting that it can resist the attack from sulfate ion from soil and water. And which type of environment particularly aggressive and requires the use of sulfate resistant cement? Coastal areas with salt water exposure are the scenarios where we are going to use what? Sulfate resistant cement. Okay. Then, how does sulfate resistant cement achieve its resistance to sulfate attack? Then, by controlling the proportion of C3A in the clinker, we are going to have this specific property. It controls the sulfate proportion of C3A to enhance the sulfate resistance. And in which type of structure sulfate resistant cement is commonly used? Dam and marine structure. Okay, wherever sulfate attack is prone, we are going to use this one. Then what is the potential drawback of using sulfate resistant cement for construction project? The sole reason here is higher cost. Okay, it is costly, that's why it is the only potential drawback. Then what is the primary characteristic of white cement? Okay, color consistency. Okay, white cement is known for its consistent white color for its use in architectural and decorative application where aesthetic is the prime concern. Now, what is the primary application of white cement in construction? Obviously, aesthetic purposes, which is architectural and decorative finishes. And how does the cost of white cement compare to ordinary Portland cement is? Then white cement is obviously more expensive. As we are moving further from OPC, the cost is obviously going to vary and more possibly in higher range. And primary ingredient that contributes to the white color of iron cement, it is the low iron raw material. Okay, reduction in iron raw material is going to lead the whiteness of that white cement. And which type of structure benefit most from the use of white cement? Heritage and architectural structure. The sole use you will be seeing regarding white cement is the aesthetic necessities, where it is required in heritage structure and architectural structure. Then what is the primary advantage of using colored cement? Obviously aesthetic appeal, it is going to be colored cement, means a specific color will be there, and mixing it, having the concrete in that colored cement will be giving that specific look. Then how are the color pigments added to the colored cement? During grinding of the clinker, the pigments are added, right? And which factor influences the final color of colored cement concrete? Obviously the water cement ratio is going to influence the final color of colored cement concrete. Then what is the recommended practice when using colored cement in the project? Using consistent water cement ratio, because it is going to give out the exact color which is required for that specific structure. Okay, using the consistent water cement ratio. And which type of structure often benefits from the use of colored cement? Industrial structure. We are not going to use in industrial heritage structure. We are not going to use it in industrial building or roadway or highway or underground tunnel. The heritage structure where aesthetic appeal is the main concern, we are going to use the colored cement. What is the primary characteristic of hydrophobic cement? Means phobia of what? Water. Water repellency. Okay. Wherever hydroproofing or waterproofing is required, we are going to use hydrophobic cement in the concrete mix. And how is the water repellency achieved in hydrophobic cement? Means how that hydrophobic cement is being hydrophobic. By incorporating the hydrophobic agent in the mix, we are going to achieve the water repellency. Then in which type of construction hydrophobic cement is commonly used? Obviously it is not going to be mass concrete structure. Here we are going to require low heat one, then not oil well, not high-rise building. In high-rise building, strength will be the concern. In underwater structure, hydrophobia of the concrete mix is the main necessity. That's why in underwater structure, we are going to use hydrophobic cement. Then how does hydrophobic cement affect the workability of concrete? It reduces the workability. Also remember, hydrophobic cement reduces the workability because it has what? Water repellent agent. Hydrophobic agents are present in the hydrophobic cement. What is the potential drawback of using hydrophobic cement? Reduce bond strength. Okay. Hydrophobic cement may have reduced bond strength with certain material due to its water repellent properties. And what are the primary characteristics of expansive cement? Not expensive, expansive cement. Volume expansion after setting. Okay, it is the primary characteristics of expansive cement. It undergoes controlled volume expansion once it sets. Then what is the primary application of this one, expansive cement? Repairing cracks in concrete. Obviously when this expansive cement will be going inside the crack, then it is going to expand so that it will be filling it out properly. Then how does expansive cement achieves its volume expansion after setting? By incorporating expansive agent like ettringite. Okay, by adding ettringite, we are going to have that expansion property. The correct answer is option D. What precautions should be taken when using expansive cement in construction? Avoiding the use of curing compound should be the care that we should take while we are using what? Expansive concrete. Cement, not concrete, cement. Now, which type of structure often benefits from the use of expansive cement? Obviously dams and reservoirs. Okay. In dams and reservoir, whatever the thermal cracks are there, whatever the cracks because of the setting of the structure is there, we are going to fill them up with the expansive cement. Once the expansive cement goes inside that void or crack, it is going to expand properly by filling out the voids. And it is most necessary in structures such as dam and reservoir because we seek this specific thing over there, which is water tightness. Then what is the primary characteristic of high alumina cement? Okay, high alumina content is the primary characteristic out of these options. Then how does high alumina cement achieve its resistance to high temperature and corrosion? By incorporating high alumina content. The high alumina content contributes to high alumina cement's resistance to high temperature as well as corrosion. The answer is option D. And in which type of construction is high alumina cement commonly used? In marine structure, we are going to use the high alumina cement because it offers resistance to sulfate attack as well as corrosion. Then how does high alumina cement affect the early strength development of concrete? It accelerates the early strength development. Then what is the potential drawback of using high alumina cement? Is the high cost budget. What is the primary characteristic of oil well cement? Resistance to oil penetration. We are going to use this specific kind of cement in oil well construction because it has the property of resistance to oil penetration. Then in which type of structure oil well cement is used? This cannot be more obvious. The answer is oil and gas well. Where oil penetration is the possibility, we are going to use oil well cement. Okay, oil well cement means it is going to resist the entry or seepage of oil inside the structure. Thus, it is being called as oil well cement. How does oil well cement achieve its resistance to oil penetration? Okay, by incorporation of hydrophobic agent. Okay, by incorporating liquid phobic agents. What are the primary challenge associated with using oil well cement? Okay, controlling the gas formation is a problem with oil well cement. What is the unique property of oil well cement compared to other cement types? It has shorter setting time. Okay, it sets early. Now, what is the primary application of masonry cement in construction? Architectural finishes is the primary application of masonry cement. Then how does masonry cement differ from other cement type? It is blend of OPC plus additives. Okay, it is nothing but OPC plus some special agents. What is the primary advantage of using masonry cement in mortar? It gives better adhesion to masonry units. Then in which type of construction is masonry cement commonly used? We are going to use obviously in brick and block masonry. Then what is the potential drawback of using masonry cement in structural application? It has reduced bond strength. Then what is the primary characteristics of air entering cement? See, air entering cement is used in colder climates. Alright, thereby the answer being entrant air bubble for freeze thaw resistance. Okay, freezing and thawing resistance is incorporated by entering air bubbles. And how does air entering cement contribute to improving durability in concrete? See, it provides air void for expansion during freezing, and those same air voids are utilized when the concrete is thawing. Okay, thereby correct answer by providing air voids for expansion during freezing and thawing. In which type of structure is air entering cement is commonly used? The answer is cold climate regions. How does the presence of air bubble affect the compressive strength of cement? Obviously, when we are saying that voids are present in concrete, then it is going to reduce the compressive strength. What are the important consideration when proportioning concrete with air entering cement? We achieve proper air content. Okay, we achieve proper air content. What is the primary characteristic of high early strength cement? Okay, rapid early strength development obviously is going to be the answer. And how does high early strength cement contribute to efficient construction practices? It accelerates the construction time. See, its early strength is being achieved, less time is getting consumed, thereby it will be accelerating. It will be reducing the construction time. It accelerates the construction process. Answer is B. And in which type of structure high early strength cement is commonly used? In high rise building, we are going to use high early strength cement. And how does high early strength cement affect the long-term strength of concrete? It increases the long-term strength. Then what is the potential limitation of using high early strength cement? It is available in a limited portion. That's why this is the only potential limitation. Then what is the primary supplementary material for producing blast furnace slag, and answer is going to be blast furnace slag. It is the byproduct of industries, and using this material we are going to enhance the property of cement, as well as it will be reducing carbon emissions. Then how does BFC, that is blast furnace cement, contribute to reducing carbon footprint? Okay, we just discussed it, we just saw this. It decreases the carbon emissions, okay, because it is reducing because it is utilizing or reducing a byproduct from an industry. In which type of structure we are going to use blast furnace cement? We are going to use it in bridge piers because its durability and resistance to water corrosive elements, means whatever the corrosive elements that are present in water, we are going to use it in bridge pier. And how does the use of blast furnace slag in blast furnace cement affect the concrete properties? It obviously going to add on to durability, and it is going to help reduce the heat of hydration, right? What is the potential drawback of using blast furnace cement in construction? Higher cost. Okay, the problem whenever you are doing something to OPC, it is going to increase in the cost, increase in the budget. So these were the remaining 105 questions regarding properties of cement and concrete. I will see you in next one. Till then, take care.